All viewers and dear students, today we have a new question number 5 in exercise 4.3 unit number 4. Let's come start find all the relative extrema for the function f of x. Part A, f of x is equal to x cube minus 3x square plus 1. So relative extrema means that we are finding relative minimum or relative maximum. So first of all, we are differentiating this function with respect to x. We are differentiating with respect to x on both sides of this equation. On both sides dy by dx f of x is equal to dy by dx x cube minus 3x square plus 1. So we can write here individually apply dy by dx x cube minus 3 is constant we take from outside the function, and dy by dx x square plus here is no variable is present, so we are applying here dy by dx 1. Now according to the power rule we write f dash x according to this power rule nx n minus 1. This is the exponent or power rule. Here we are applying here according to this rule 3x square 3 minus 1, and for the derivative of this function we get here 1 minus 3. Here 2 is the power and 2x 2 minus 1, and for the derivative of this function is x is 1 and plus constant derivative is 0. This is the rule of any constant derivative with respect to x we are finding, so the result will be equal to 0. Now simplify this term, we get 3x square minus 6x. This is f dash x. Now we are finding the critical values for this point. For critical values, we put f dash x is equal to 0. So here we put f dash x is equal to 0. This implies that 3x square minus 6x, and here we take common 3x is common, x is remaining, and 3 multiplied by 2 we get 0. So dividing here it means that 3x is equal to 0 or and x minus 2 is equal to 0. Dividing both sides by 3, so the result will be equal to 0, and here we change this result. The right side x is equal to 2, both are cancelled, x is equal to 0 and x is equal to 2. So the critical points we get x is equal to 0 and x is equal to 2. Now we are for the relative maximum, relative minimum, we are negate the second derivative of the function. So we are differentiating. Again we are differentiating the first derivative f dash x on both sides of the equation. Dy by dx f dash x is equal to dy by dx 3x square minus 6x. Now we first try we change in the double derivative. is equal to, here we are using the power rule, 6x minus 6x gravity is 1, 0, then f double dash is equal to 6 into 0 minus 6. So the result is minus 6, which is less than 0. So the function, function is relative maximum. Function is relative maximum, and maximum value is and x is equal to 0 is equal to, we put the original function f 0 cube minus 3 into 0 square plus 1, 0 cube. So 0 cube is going to solve 0, everything is 0, we get here 1. So the maximum, relative maximum value 0 and 1, we get relative maximum value, we get here 0 and 1. 1 we get this. Now we apply the second result when x is equal to 2, then f double dash is equal to 2, 6 into 2 minus 6. In the second derivative we replace here and x, and f double dash 2 is equal to here 12 minus 6, we get 6, 6 is greater than 0. So here the function is a relative function is relative minimum, and minimum value is and minimum value and x is equal to 2, f of 2 is equal to 2 cube minus 3 into 2 square plus 1 is equal to what? Here 2 cube we get 8, and 4 multiplied with 12 plus 1 we get here 9. 9 minus 12 is equal to minus 3. So the relative minimum value 2 and minus 3. Thank you very much for watching. Please subscribe my channel and share. Is equal to x cube plus 6x square, x cube plus 6x square plus 9x plus 2, 9x plus 2. We are finding the relative maximum in the relative minimum function. First of all, we find the critical points. For the critical point, we put the first derivative is equal to 0, and we are proceeding for the second derivative to check the relative maximum or minimum. First of all, this function we are differentiating with respect to x. We are differentiating with respect to x on both sides of the equation. So dy by dx, f of x, dy by dx, x cube plus 6x square plus 9x plus 2. Derive this function f dash x and 3x square plus 12x 3 is the power. We are using the power rule. This is the power rule. Nx n minus 1 according to this rule here is equal to 3. We can write 3x 3 minus 1 and further is equal to 3x x cube derivative we can write in this form. Now plus x derivative is 1 and plus derivative is 0. Now for the critical points, put f dash x is equal to 0. So 3x square plus 12x plus 9 is equal to 0. Here we take common, 3 is common, and we get here x square plus 4x plus 3 is equal to 0. Dividing both sides by 3, both are cancelled. We get here x square plus 4x plus 3 is equal to 0. Now we are making factorization of this function. First and last one we multiply, so we get 3, and we can write this function x square plus 3x plus 1x plus 3 is equal to 0. F1 plus 3 we get middle term, we get 4, and 1 multiplied by 3 we get first and last term. Now we are making pairs, and x is common, x plus 3, and 1 is common, x plus 3 is equal to 0. X plus 3 is equal to 0. X plus 1 is equal to 0, or x plus 3 is equal to 0. X is equal to, we change this result here, minus 1, or this result is also changed, x is equal to minus 3. So the critical points x is equal to minus 1 and minus 3, that is the critical point. Now we are finding the second derivative of the function. Here, so first function we get here, first function derivative 3x square plus 12x plus 9, that was the derivative. Now double derivative we are finding for the second function. We get here 6x plus 12. 2 multiplied by 3, 6x, x derivative is 12, and 9 derivative is 0, constant. Now we apply the limit critical points. If when x is equal to minus 1, then double dash is minus 1 is equal to 6 into minus 1 plus 12. We get double dash minus 1 is equal to minus 6 plus 12, that is 6. 6 is greater than 0. So the function is relative minima. So the function is relative minimum, and minimum value is at x is equal to minus 1. In the original function we put minus 1 is equal to minus 1 cube plus 6 into minus 1 square plus 9 into minus 1 plus 2. So we get minus 1 plus 6 minus 9 plus 2. If we add this one, both are this is negative, we get here minus 10 plus 8, we get minus 2. Minimum values x is equal to minus 1 and minus 2. Similarly, when x is equal to minus 3, then f dash minus 3 is equal to 6 into minus 3 plus 12. We get minus 18. Minus 18 is minus 18 plus 12. So we get minus 6. Minus 6 is less than 0. So the function is relative maximum. So the function is relative maximum and maximum value is at x is equal to minus 3, f minus 3 is equal to minus 3 whole cube plus 6 into minus 3 square plus 9 into minus 3 plus 2 is equal to minus 27. 9 plus 54 minus 27 plus 2. If we add this result, that is cancel minus 24 minus 54 cancel, we get here 2. Maximum value is x is equal to minus 3 and 2. That is the final answer. Thank you very much for watching. Please subscribe my channel and share this video with your friends. Thanks again.
We have a topic of one of
Assalamualaikum all
inflection.
viewers.